Good morning. I hope you all are safe at home. I would urge that you all are enjoying online materials to understand various concepts of economics. Today, we'll discuss about an important concept which is known as auto-regressive distributed lag, or in short form ARDL. So, as I told in the class, that when you get data, so first you have to do it stationary. That means when you get any time series data, you have to make stationary. So when you make the stationary, you first try to understand whether data is stationary at level or data is stationary at first difference. So in general co-integration techniques or Johansson co-integration techniques, if the variable are stationary in the same level, then only we can apply the techniques. But in maximum cases, when we have a variable more than two, or you have multiple regression type concept, and also it takes the autoregressive form, so that all the variables are not stationary at the same level. That means some variable are stationary at level and some variable are stationary the fast difference. So in that time, we use ARDL instead of Johansson co-integration test. So in today's class, I'll take you through the various concept and salient feature of ARDL model, and how we'll know that ARDL model is helpful for our economic understanding, and what are the associated tests or diagnosis tests is required for a good ARDL model. So I'll take help of PPT and some equations for your understandings. So for your information, I have already sent the material to PDF file. One is theoretical part, another is practical part. You have already gone through that. So now, by looking at this video, you will follow my lecture. And I'm also planning another class, practical class or hands-on experience class, where I will explain how we can do AirTail with the help of eVuge. So let's discuss the concept of AirTail. So AirTail, let me just share that AirTail. So as you know that the short form of auto-regressive distributed lag is ARDL. So this ARDL has some salient features. The first salient feature of ARDL is that it uses the combination of endogenous and exogenous variable. It takes lag value of dependent variable, current and lag value of independent variables. This model is combination of I1 and I0 order of integrations. No variable are integrated of order 2. That means if any variable is integrated in the second difference, we cannot use the ARDL model. So this is the basic premises. Either it should be the combination I0 and I1. It should not be the combination of I1, I0 and I2, because in I2 you lose the maximum data properties. Further, ARDL model is comparatively more efficient in case of sample where it is small and finite one. We apply ARDL for getting long run estimates, which is unbiased one. So in a simple functional form, we can write GDP equal to the function of INF, INV, and MS. Here INF means inflation, INV means investment, MS means money supply, GDP means gross domestic product. So we can write that functional form the following equation: GDP at time period t equal to beta 0 plus beta 1 INFT plus beta 2 INFVT plus beta 3 MST plus ET, where you know that beta 0 is intercept of different variable and beta 1, beta 2, beta 3 are in slope coefficient of independent variables, and ET is the error terms. So in Airtel model, we try to understand whether there is a equilibrium relationship exists in the long run as well as short run. If the long run equilibrium relationship exists, is there any short run disturbances also there? That also you try to understand. So there is one test is there which is known as bound test. With the help of bound test, we understand whether there is a long run conjugation or relationship exists between the variables or not. So for bound test, we have null hypothesis, we have alternative hypothesis that. So null hypothesis that there is no conjugation or relationship exists among the variables, and the alternative hypothesis that there is a conjugation or long run relationship among the variables. Or in a mathematical way, you can write H0 equal to beta 0 equal to beta 1 equal to beta 2, or H1 so beta 0 equal not beta 1 equal not beta 2. So that means if we reject null hypothesis, null hypothesis means there is no conjugations. We will expect there is a conjugation or long run relationship. Or if we expect null hypothesis means, that means there is no conjugation between the variables. So in order to understand that, so there is a one thumb rule is there. So when you will do the when you will carried out that bound test, you will get one F statistic and you will get upper bound value or lower bound value. So if the calculated F statistic is greater than upper bound, so that means there is a co-integration exists between the variables. If the calculated F value is less than lower bound, then co-integration does not exist in that case. So in another scenario, if F statistic is in between lower bound and upper bound, so then we cannot interpret the result. That means we cannot tell whether there is a conjugation is there or not. So if there is a conjugation, that means your calculated F value is greater than upper bound of your F statistic, then we will call it there is a conjugation is there. So if the conjugation is there, then we will go for Airedale model. If it's Airedale model means we will report ECM, that is error correction mechanism. So if there is no conjugation, then we have to stop there only using Airedale. If there is a conjugation is there, then we will go for error correction mechanism. As I told in the previous class, what is error correction mechanism? Error correction mechanism shows when there is a long run when there is a relationship, we want to see in the short run, if the relationship is disturbed, how much time it will take to again catch the long run equilibrium. So that means if we get error correction mechanism minus 0.25, so that means in annual data, it will take 4 years to catch the equilibrium. Or if it is the minus 0.50, it will take 2 years. So 0.50 means it is a 50%, means 2 years. So this ECM is always negative and it should be significant. So we'll discuss there are various diagnostic tests or goodness of fit test for Airedale model to tell this Airedale model is a good model. So before that, I'll little bit explain the mathematical actual specification of the Airedale model. So in case of mathematical specification of Airedale model, we can see this actually specification. This specification also I have given in your actually study material. The functional form of the model can be represented as ln CO2 is a function of ln GDP, ln EC and ln FDI. That is ln CO2 equal to CO2 emission, that is carbon emission, and ln GDP, that is gross domestic product, and ln EC equal to energy consumption, ln foreign direct investment. So if we write the above functional form, we can write ln CO2 equal to beta 0 and beta 1 ln GDP plus beta 3 ln ECT plus beta 3 ln FDI plus ET, like our GDP investment inflation functions. So there are also beta 0 is here is also beta 0 intercept, and beta 1, beta 2 are the coefficient of the independent variables. So you can see this second equation where that this specification is told that, or specifying that the dependent variable is also function of lag of dependent variable and the lag of other independent variable. So ln CO2 equal to beta 0 summation I1 to n beta 1 ln CO2 t minus I plus summation I0 to n up to n2. Like that, beta 3 also I runs from 0 to n3, and beta 4 coefficient also run from 0 to n4. That means it takes lag and the current value of the dependent variable as well as independent variable. So if you see the equation number 3, if there is a long run relationship is there, that means there is a co-integration is there, then this theta ECM shows the error correction mechanism. So it will come negative, and according to that figure, we will interpret actually what is the period of adjustment, what is the duration or the period of adjustment. Then let's again come to our discussions where you will discuss various tests of goodness of fit of our Airedale model, or which we call is diagnostic test of the Airedale model. So there are various type of diagnostic test or goodness of fit of the Airedale model. The first one is normality test. The second one is serial correlation test. The third one is heteroscedastic test. The final, but not in the list, that is the stability test. So let's explain one by one for your understanding. So the first one is normality test. This normality test, we use Jacobera test. We want to know whether our distribution is normal distributed or not. So that's why we take, there is a two hypothesis that data follows normal distributions and H1 equal to data does not follow normal distributions. So if we reject that data follows normal distribution, that means we expect data does not follow normal distribution. So if we expect the data follows normal distribution, then we will reject data does not follow normal distribution. According to that, your interpret will result. If a probability value is less than 0.05, then data follows normal distribution, or if it is greater than that, then data does not follow normal distributions. Then come to the second type of test, which is known as serial correlation test. So in case of serial correlation test, we use Q statistics or LM statistic to know whether that serial correlation or autocorrelation is there among the variable or not. Here we take null hypothesis that there is no serial correlation, an alternative hypothesis that there is a serial correlation. That means if we reject hypothesis there is no serial correlation, that means there is a serial correlation between the variables. So if the calculated value is greater than tabulated value, that means there is a serial correlation among the variables. And if we expect that, then that means there is no serial correlation among the variables. The next test is heteroscedasticity test. For heteroscedasticity test, we have Bruce-Pagan-Gottfried test, Harvey test, Arch test, white noise test, Glaser test. Here also we have a null hypothesis which shows error terms are heterogeneous, or we call it error terms are not homogeneous, and the alternative hypothesis that error terms are homogeneous. So if we reject like null hypothesis error terms are heterogeneous, then we have homogeneous, error terms are homogeneous. So the final test is stability test. So the stability test is one graphical test of knowing whether our model is stable or not. So in order to know that, we use that two type of test. One is Kusum test, another is Kusum-Karp test. So in these two tests, we have two bandwidth. That means upper bound and lower bound. If our data lies between that upper bound and lower bound, that means our test is stable. And if it's going beyond that bandwidth, we call it that our data is not stable. So thank you all for your patience listening. So in the next class, what I'll do the hands-on experience or practical class on ARDL with the help of actual reviews, where I'll show how to do the ARDL concept with reviews. So meanwhile, you see my lecture and try to understand, and if you have any problem, you just contact me. So stay at home and stay safe.